Today's transformation lesson is on reflections. So when you reflect a figure or flip it across a line, each point of the figure maps onto another point. It's the same distance from the line, but on the other side. The orientation of the figure reverses. Think about looking at yourself in a mirror. In geometric terms, if we're looking at the pre-image and we're looking at the image, both of these figures, in this case it's a person, but both of these figures are going to be the same distance from the line of reflection. Obviously, this is just a model, but the same would go for reflecting across a line in the coordinate plane. Every point reflects the same distance. So just a little background on reflecting in a line. So a reflection across line M is called a line of reflection, and this is a transformation with the following properties. Line M is this line here. So if a point is on the line of reflection, then the image and the pre-image are the same point. If we look at our model, an example of this would be point A. And I'm just going to draw an arrow. You can see that A and A prime, so image and pre-image, are both on the line of reflection, which is line M. If a point is not on the line of reflection, then the line is the perpendicular bisector of the segment joining the 2 points. So for an example of this, let's take a look at point B as the pre-image and B prime as the image. So these 2 points are equal distance from the line of reflection, but if you connect these 2 points, this blue line is going to form a right angle, or it is the perpendicular bisector of our line of reflection. If we move on to looking at reflecting a point across a line in the coordinate plane, we are going to first look at number 1, which is where or when we're reflecting point S, which is at 3, 4. So let's graph that. So we're reflecting point S across y equals 1. So if we're reflecting point S across the line y equals 1, this is going to require you to graph the line y equals 1, which is the line in the coordinate plane where every point on that line, so no matter what point I draw, every point has a y value of 1. That would be in this location here. So the line I just drew, this line, is the line y equals 1. In order to reflect, we need to just count the distance. So if point S is 3 units away from our line of reflection, then we're going to go 3 units in the other direction, and we're going to plot our image point, which is S prime. S prime is going to be our answer. This point is located at 3, -2. So again, for the line of reflection, you want to make sure that you have the same amount of units above and below the line. Here we have 3 units above the line. We counted 3 units below the line as well, and that is where our final answer is. For number 2, we're reflecting point R across the line x equals 1. Point R is at -2, 1, and the line x equals 1. So x equals 1 is the line in the coordinate plane where every x value on that line is equal to 1, and that is this line here. If point R is 3 units on the left side of x equals 1, we are going to reflect this 3 units to the right side, and we're going to plot point R prime, which is currently located at 4, 1. And this here would be your final answer. Students' biggest issue with problems like this is understanding where to graph the lines x equals or y equals. So when you're graphing a line x equals, this is going to be a vertical line. Okay, it's a line where every x value on that line is equal to whatever you're graphing. So for example, x equals 1. We graph the line where any point on this line would have an x value of 1. If you're graphing the line y equals, this is going to be a horizontal line. And again, it's the line where every point on that line is equal to your y value. We have an example here of y equals 1. Any point on that line has a y value of 1. For the next example set, we are reflecting a figure, not just a point, so a figure across a horizontal or vertical line. So we need to pay close attention to the directions. It says triangle ABC has vertices A at -3, 1, B at -2, -3, C at -4, -2. We need to graph triangle ABC and its image across the given line. So let's start with number 1, where we are graphing across the line x equals -2. Well, x equals -2 is the line located at your x value of -2. It's a vertical line. Point A, we need to graph, so we're graphing all 3 of these points for the triangle. Point A is located at -3, 1. B is located at -2, -3. And C is located at -4, -2. I'm going to connect these points, for my triangle. And now when I perform the reflection, I need to reflect every point. So it doesn't matter which side of the line it's on, you have to be specific to the individual point. So for example, point A is 1 unit on the left side of our line of reflection, so A prime will be 1 unit to the right. Point B is on the line of reflection. So back when we first talked about reflections on the first page, if the point is on the line of reflection, then its image is also on the line of reflection. And point C is 2 units to the left, so we're going to go 2 units to the right and plot C prime. I'm now going to connect the points to form my image. And I'll shade this in just so we can clearly see the image. Our image is the pink triangle. That is our final answer. So even when you are working with a shape, you work with an individual point. It might get confusing because sometimes you'll have points on both sides of the line, but if you focus on one point at a time, you reflect that point only, and then your final answer should always be correct. So here's a little note. The pre-image and image points are the same distance from the line of reflection. Does not matter which side you are on. That is always true. If we look at number 2, for number 2, we're graphing the same triangle across the line y equals 0. Remember that when you're graphing y equals, you're graphing a horizontal line, and it's the line where the value would be the value of every point on the line. So any point on that blue line has a y coordinate of 0. Our triangle is located at A of -3, +1. B is at -2, -3. And C is at -4, -2. We connect to these points, and we focus one point at a time to reflect this across the line of reflection. So starting with point A is 1 unit above, so we go 1 unit below. That's going to give us A prime. Now point B, it's on the other side of the line of reflection, but that's okay because we work 1 point at a time. So point B is 3 units below this line of reflection. I'm going to graph B prime 3 units above. And C is also below the line of reflection. It's 2 units below, so regraph the point 2 units above. Connect your points to form your reflection image, and I'll highlight those in purple. We can see our final answer a little better. This triangle is your final image triangle, reflected across the line y equals 0. Okay, so there are a couple of rules that we should know, and these rules will be helpful when you are writing out. So when you're writing transformation rules, this is when they become very important. The first one is reflecting in the x-axis. So this is when you are only reflecting across the x-axis. You are not reflecting across a line such as x equals 1 or y equals 2 or whatever the case is. You are specifically reflecting across the x-axis. To reflect a point in the x-axis, you're going to multiply the y-coordinate by 1. And you can see that in this diagram here. We're reflecting across the x-axis. So if we look at point A is at 4, 1. If we look at point A prime is at 4, -1. The difference is our y-coordinate was multiplied by -1. So there's a specific rule, and the rule is that the original ordered pair x, y maps onto x, -y. So whatever your x and y value is, make that y value negative, and that is your reflection in the x-axis. A reflection in the y-axis. So to reflect a point in the y-axis, you multiply the x-coordinate by -1. If we take a look at our model over here, we're reflecting across the y-axis, which I just highlighted in blue. We are looking at point A, which is at 2, 3, compared to A prime, which is at -2, 3. The only difference is that our x value became negative. So to write out a rule for this, we would write x, y maps onto -x, y. So a helpful trick for remembering these is to think of the opposite. If you're reflecting across the x-axis, you make the y-coordinate negative, so they're the opposite coordinate. If you're reflecting across the y-axis, you make your x-coordinate negative. These rules are so important to know. Just like in yesterday's assignment, you will be asked to write a rule for the reflection, and you're expected to know to write it in this format. Number 1, for these two problems, we're just reflecting a point. For number 1, we're reflecting point S, which is at 3, 4, across the y-axis. So the y-axis is this line here. I'm just going to label it y-axis. And then because we're reflecting across the y-axis, remember the rule tells us that your ordered pair x, y will have a negative x coordinate and a positive y coordinate. You make the opposite coordinate negative. So if 3, 4 is our point, I can easily write out that S prime is going to be at negative 3, 4. Okay. The only difference is that your x coordinate became negative. So I can plot point S prime at negative 3, 4. I can double check my work by counting to see the distance. S is 3 units away from the y-axis. S prime is 3 units away. So this is the correct answer for S prime. For number 2, we are reflecting point R, which is at negative 2, 1, across the x-axis. The x-axis is located here. And remember that if you're reflecting across the x-axis, then that means the rule has you flip the opposite point. X, y maps onto positive x, negative y. If point R is located at negative 2, 1, when we apply the rule for R primed, the x coordinate will remain at negative 2. The y coordinate is going to change signs, so this becomes negative 2, negative 1. The difference is your y coordinate became negative. You could also check the distance. R is 1 point above the x-axis, R prime is 1 point below the x-axis. So you can always check to make sure that the rule of the same distance applies, but make sure you also know how to apply or you understand what the actual reflection across the x and y axis stands for. So I have that as a note for you to copy down. It says use the rules for reflecting across the x or y axis. You can check your work by counting the distance from the line of reflection, which is what we've been doing in the previous examples. So while you do that, I'm just going to make the answer a little bigger on these for you to see. For the next example set, we are now reflecting a figure. We're going to be reflecting triangle ABC with vertices at A of negative 3, 4, B at 0, 1, C at 4, 2. We're going to graph ABC and its image under the given reflection. So for number 1, we are reflecting across the x-axis. And I'm actually going to set up a table just because I think that will organize my work on this one. So I'm going to write out in my table that I have my original ordered pair x, y, and that when you're reflecting across the x-axis, this maps onto a positive x coordinate and a negative y coordinate. The only thing that changes is the sign of your y coordinate. All right, I'm going to do each point individually. That's what you want to do so you don't make any mistakes. First, I'm going to graph my image. Point A is at negative 3, 4. Point B is at 0, 1. Point C is at 4, 2. We are reflecting across the x-axis, which is this line here. So now I'm going to apply my reflection rule, starting with point A. Point A is located at -3, 4. So when I apply the rule, A prime is going to be located at -3, -4. And I'm going to plot that point. Point B is located at 0, 1. This tells me that B prime is going to be at 0, -1. Again, all I'm doing is multiplying the y coordinate by -1. And lastly, point C, which is located at 4, 2, is going to have the reflection rule C prime of 4, -2. I'm multiplying that y coordinate by -1. Now that I found all 3 points, I am going to connect those dots, and this is my final graph. Reflected across the x-axis. For our next example, we are going to be reflecting across the y-axis. So reflecting across the y-axis tells us to use the rule of x, y maps onto -x, y. So in this function, what we'll be doing is we will be multiplying our x coordinate by -1. Starting by plotting our points, we're using the same a, b, and c value as number 1. Our a value is at -3, 4. B is at 0, 1. C is at 4, 2. We are reflecting across the y-axis. That is this line here. Starting with point A. Point A is at -3, 4. When we apply the transformation rule, A prime is going to be -3 times 1, which is +3. Sorry, -3 times -1, which is +3, 4. For point B, located at 0, 1, when we apply the transformation rule for B prime, we have our x coordinate of 0. 0 times -1 is still 0. So B is actually on the line of reflection, which means B prime is also going to be on the line of reflection. And for point C, our last point, the original ordered pair of point C is located at 4, 2. When I apply the transformation rule for C prime, this becomes -4, 2. I now have to connect my A prime, B prime, and C prime. Be very careful. I use the same color here. I probably should have broke those up, but I'll highlight my final answer for the reflection image A prime, B prime, C prime. You always have to work one point at a time. Trying to do the whole image at once is going to be difficult, especially when you have points on each side of the reflection line, like this one here, like number 2. Okay, the last reflection we're looking at is a reflection across the line y equals x. So the line y equals x is a line in slope-intercept form. It's the line y is equal to x plus 0. So that is the line that you will be graphing, and I'll show you that when we go over our examples. To reflect a point in the line y equals x, you interchange the x and y coordinates, which means you switch the x and y coordinates. If we look at our model over here, here's our line at y equals x. If we look at point A has a point at negative 5, 2. A prime is at 2, negative 5. So we literally switched these points. That's all we did, is we switched them. So the rule tells us that x, y becomes y, x. You are literally switching those points. Similar to the previous problems we're doing, we have to graph our image and then we have to reflect it across the given line. So we are graphing the image of W at 2, 2, X at 4, 1, Y at 3, negative 3, and Z at 0, negative 4. This is going to form a quadrilateral, or a four-sided figure. And we are graphing this across the line y equals x. Y equals x is the same thing as y equals x plus 0 in slope-intercept form. That means you would plot a point at 0 for your y-intercept, and the slope is 1 over 1, so up 1 over 1, up 1 over 1. And this here is the line y equals x. Again, it's found by slope-intercept form. So now to apply the transformation rule that we talked about above, we have to interchange each point. So we need to interchange any point that's given. The rule tells us that x, y is going to map onto y, x. We switch each point, or each value. Starting with point W. Point W is located at 2, 2. When I interchange the points, it just maps onto itself. 2, 2 interchanged is also 2, 2. So W prime is located at the same spot. It is on the line of reflection. Point X is at 4, 1. Point X prime is going to be at 1, 4. Those points are switched. When we plot that, we go over to 1 up to 4 for point X prime. Point Y is currently at 3, negative 3. Y prime, when you switch those, is going to be at 3, negative 3, 3. And lastly, point Z, which is located at 0, negative 4. You're going to flip these points, and Z prime is located at negative 4, 0. Connect your 4 points for your quadrilateral, and that is going to be your final answer. For number two, we are graphing the same quadrilateral. Let's see if I can just save us some time here and grab it from this example. This time we are reflecting across the line y equals x. So y equals x is the same thing as y equals negative x plus 0. Negative x plus 0 is a negative slope, so it's actually a reverse line, or it looks like it's a flipped line from what we just graphed in number 1. This line here is y equals negative x. Now, the rule does change a little bit. When you are reflecting across y equals negative x, you actually have to make the whole function negative. Because you made your slope negative, and we graphed a negative value slope, our rule is now going to become x comma y maps onto negative y comma negative x. We are making everything negative. So when we do that, and you might want to make a note on your notes that's what we just did here, that this rule, and I'll actually write it and I'll highlight it, is x comma y maps onto negative y comma negative x. All right, when you have a negative slope, everything becomes negative. So when we apply our rule, point W is currently located at 2, 2. When I apply my transformation rule, I interchange the points, but I also make them both negative for negative 2, negative 2. Point X is at 4, 1. I'm going to change the points and make them both negative for x prime at negative 1, negative 4. Point Y is at 3, negative 3. Y prime is going to be at positive 3, negative 3. You switch the points, but you also make them both negative. That point reflects onto itself. So y prime is in the same location. And lastly, point Z, which is currently at 0, negative 4. When we switch the points, it becomes Z prime at positive 4, 0. When we connect our points for our final image, and I'll highlight these so we can see what it looks like. Our final graph, or our final reflection, looks like this. Okay, so I am quickly going to make a note of reflection rules for you, and I think that all of you should do this as well. So everything we learned today. So the first rule, if you are reflecting across a line, you want to mirror or keep the same distance from the line of reflection. So I'm going to say count the units and keep, the same distance on each side of the line of reflection. This was found in example set 1 and 2. Our second rule is reflecting across the x or y axis. Reflecting across the x-axis is when you switch or multiply your y-coordinate by 1. And reflecting across the y-axis is when you have your original point and you multiply the x-coordinate by 1. This was example set 3 and 4. And lastly, reflecting across, I'm going to say y equals x, which is the rule x comma y maps onto y comma x. You interchange your points. And then also we looked at reflecting across the line y equals negative x, which is when you have your original coordinate. You switch your points, but you also make them both a negative value. So that negative is important on that last one. I'm going to highlight the negative signs. You still reflect or switch your points, but you also make them negative. And this was example 5. So we went through 3 different types of reflections, and within them we have certain rules. So make sure you keep this in mind. Please let me know if you have any questions, and that is it for the notes for today.